Hello, my name is Alexa, and this is my serial dilution. We'll be using a serial dilution and spread plate to quantify how much bacteria is in our sample. We are using the assumption that one cell, aka a CFU or colony forming unit, forms a single colony. We will compare the number of colonies on our plate to the dilution factor and how much volume we plated onto the spread plate to determine how many CFUs are present per milliliter. We want the number on our plate to be a countable number between 30 to 300. This allows us to estimate the number of CFUs in our original sample, as we took the dilution factor and spread plate volume into account. And so we will be starting with 10 milliliters of an undiluted sample, and then transferring 1 milliliter into a tube that has 9 milliliters of water. Each of these tubes already has 9 milliliters of water. We would take 1 milliliter from this now 10 milliliter tube into the next one, 1 milliliter from this now 10 milliliters into the next one, and then 1 milliliter from the 10 milliliters into the last one. So we can see there is a descending dilution that is happening, and so this is the most concentrated. This is not diluted. This is our original sample. So we have a 1/10 dilution, a 1/100th dilution, a 1/1000th dilution, and a 1 to 10,000 dilution. Those will be the most diluted. And so we will transfer 0.1 milliliters onto a spread plate that will grow a certain number of countable colonies on them. And then we will take the number of colonies on that plate times the dilution factor of the plate and divide it by the sample volume on the plate to get the number of colony forming units per milliliter. This is the serial dilution setup. So we have the first container, which has 10 milliliters of coffee. This is not diluted. We have 9 milliliters of water in each of these cups. So we will be doing a serial dilution. So I will take 1 milliliter of coffee and transfer it to the first container. Mix it a bit. And this represents a 1/10 dilution. I will take 1 milliliter from here, transfer it to the next, and mix it. This represents a 1/100th dilution. The next one, 1 milliliter to here. Mix it. This represents a 1/1000th dilution. And then 1 milliliter from here into the last one. And that represents a 1 to 10,000th dilution. So you can see the difference in the colors as we get continuously more diluted. If we plated 0.1 milliliters of our 1/1000th dilution onto a spread plate, as shown here, in an example, we would have 75 CFUs, which are colony forming units, at our 1/10,000th dilution. And like I said, we had just plated 0.1 milliliters onto the spread plate. So the equation we use to calculate will be the number of colonies times the dilution factor divided by the sample volume in milliliters. So if we had 75 colonies, aka our colony forming units, times the dilution factor of 10,000 divided by the 0.1 milliliters that we plated onto the spread plate, that means there were 7,500,000 CFUs per milliliter in our sample.